Hi guys, I thought I would just do a video of me giving you some notes today because I wanted to review the difference between permutation and combination. And then I'm going to have you kind of look over what's the difference. And then I'm going to show you something interesting with combinations in a little bit. But remember, permutation is order matters. This one, the order doesn't matter. So let's say I have 6 things and, oops, sorry, this is what I meant. Okay, so the difference between these things, it would be like, let's say those 6 people running in a race again. There's 6 people in the race. Here, I want to know, how do those 3 people finish? Like, how many ways can we get the first 3 winners? This one says, how many ways can one of those 6 people be in first place, then in second place, and in third place? So there's going to be a lot more permutations because you can switch one thing, 2 things, all 3 things, whatever, and you're getting more and more and more, whereas this is just a group. So I'm going to start with combination. So 6 times 5 times 4, 3 numbers starting with 6, divided by the second one's factorial. And I also want to show you or remind you how to cancel. So I could go 3 into 6 is twice. I can take 2 into 2. I could have also taken the 2 into 4. But regardless, all I have left is 5 times 4. And now we get 20 ways that 3 people out of the 6 can be in the first, can finish in the first half of the pack. This one, I want to know which way can they do first, second, and third. So there's nothing dividing because we're not taking away doubles or anything like that. And 6 times 5 is 30, times 4 is 120. So 120 versus 20 because order matters here. Okay, so let's say we have, let's go with CDs. You guys still use CDs, right? Let's say we have 10 CDs and you want to take 2 of them. Okay, so you envision a pile of CDs and you just are grabbing 2 together. Well, 2 numbers starting with 10, 2 numbers starting with 10, divided by the second one's factorial, cancel. There's 40 ways I can grab 2 of those CDs. But now if I'm putting those 2 CDs that I'm taking in a CD player, you know, a double CD changer, or even just picking one and then picking another, that grabbing them individually gives a placement or order. Then I'd be going like this, nothing, oh, how about I multiply correctly? Nothing cancels or anything, and so I have 90 ways of putting them somewhere as opposed to just grabbing them together. Okay, I worked this one out ahead of time because of the numbers I'm choosing. But let's say I have 20 people on a basketball team. And how many have to be on the court? 5. So how can I just say collectively, you 5 get on the court, you 5 get on the court? Well, 1, 2, 3, 4, 5 over the factorial. That's supposed to be a 1. Okay, so how about if I go 5 into 20 is 4? 4 into 4, the 20 is gone. 3 into 18 is 6. I'll go 2 into 16 is 8. So I have left 19 times 6 times 17 and times 8. 24, 30, 72, 75. I'm not 100% sure I did that number right. That's not what I got last time. 19 times 6, 54, 11, 28, 2, 7, 4, 1, 1, 8, 13, 7, 8, 9, times 8, 64, 24, 30, 72, 75, 8, 15. That's what I get again. Double checking. 19, 6, 17, and 8. So there's 15,504 ways to say, I see all 20 of you sitting the bench. I want a group of 5 to get out there right now. This one, with the same numbers, is saying, I want you to go in as guard, you to go in as forward, etc. So once I give them a position, a lot more ways. 1, 2, 3, 4, 5. Starting with 20, multiply 5 numbers. And I did this one ahead of time. 1-860-480. 1-860-480. So there's 1,860,480 ways that I can choose 20 people to take certain positions. Look at the difference, right? So order doesn't matter, order matters. Placement doesn't matter, placement matters, right? Now there's one other really cool thing. Well, it's kind of cool. It's called Pascal's triangle. Pascal was one of those mathematician guys. He actually gets credit for this when he didn't even really discover it. But what Pascal's triangle is you can find combinations. Not permutations, but combinations. And the cool thing is you don't have to memorize it once you know how it's built. So it's like you start with ones, and there's always ones on the sides. But if this is the zeroth, is that a new word? This is the 0th row. Then the next row is going to be 2 ones first. Now, as it builds, what you're really doing is always starting with a 1, and then you add the 2 numbers ahead of it. So 1 plus 1 is 2, and then there's a 1, another 1, 2 plus 1 is 3, 2 plus 1 is 3, 1, 1, 4, 6, 4, 1, 1, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, another 1. And you could keep doing this indefinitely. It's going to go on infinitely because you can always keep adding. But see, it's building a triangle. And I'm going to do a few more rows. And you notice the symmetry of it. 35, 35, 21, 7, 1. I think I'll stop there. So this is the 2nd, the 3rd, the 4th, the 5th, the 6th, the 7th row. Okay, now it's important to know which rows there are, and it's important to know that the first one doesn't count as 1. Also, now as I'm going to this way, the 1 doesn't count. So if I'm saying to count to a number, I'm going to start by counting the second one always, and I'll show you what I'm talking about. But let's say we're trying to find the combination of 4 things taking 3 at a time. Well, this ends up being the row number, and this ends up being how many numbers you count in. So look at that. I go to row number 4, 0, 1, 2, 3, 4. And I count in 3. 1, 2, 3. So the answer should be 4. Well, when I actually work it out, 2, 3, 1, 2, 3, divide by the second number's factorial, cross them out, I get 4. So this triangle is a way to do these problems extremely easily. So how about 7 things taking 6 at a time? Well, this is going to the long way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, or well, I mean 6 factorial. This one actually isn't too tough because 6, 4, 4, 3, 2, 1 would all cancel, and the answer would be 7. But it took me a few seconds to do that. If I go to the 7th row and I count in 6, 1, 2, 3, 4, 5, 6, there's the answer. Okay, so what's the combination of 5 things taking 2 at a time. 5 things, that's the row number. 1, 2, the answer is 10. So it's a very interesting way to do it. There's a ton of other things this Pascal triangle is used for. And I was going to look for a good YouTube video to find things, but then it got too much of what I wanted. This is all I wanted to show you about it. Okay, so remember, if I have dishes, well, if they're stacked, that would be a combination. If I'm placing them on a shelf, permutation. If I say there's you guys sitting in, going in my room, okay, if I say everybody sit down, then there's 20 of you go in the room. How about that? That would be combination. But once I say, gosh, sorry, it's hard to do this. Take a seat, you're taking a place, that's a permutation. Let's think of another one. If I say, how many cars could be in the parking lot? In the lot in general, then that's a combination. Once they go in specific spots, then that's a permutation, okay? So what I'm going to give you as practice is, I might attach one of these and have you mess with this using there. That's just kind of an added FYI. But I'm going to give you some of these and have you practice both permutations and combinations. So I will look forward to your work. Hope you're being safe, taking care. Miss you guys. Bye.